Welcome back to STEMLens. So in the last video, we actually did talk about the classification of matter, where we discussed matter to be anything that has mass and occupies space. We also talked about the phase, the state of matter. We talked about the phase transfer. We talked about the properties as well as the changes of matter. So if you would remember, we divided matter on a broad basis to be into two groups. That's the pure substance and the impure substance. For the pure substance, where we had elements and compounds, and for the impure substance, where we had mixtures. So in this video, we shall be focusing on the pure substance, which are the elements and compounds, and then in the next video we shall be focusing on mixtures. After that, we'll talk about separation techniques, then we'll move to the next chapter. Alright, so elements now, they say elements are distinct substances that cannot be split up into simpler substances. Such substances consist of only one kind of atom. There are over 100 elements known to date. Each of these elements is usually symbolized by a capital letter or a capital letter followed by a small letter derived from the English or Latin or Greek name of the element concerned, e.g. hydrogen H, sodium Na, copper Cu, uranium U, antimony Sb, neon Ne, etc. The elements can be categorized in several ways. Okay, before we move to the categorization of elements, let us discuss what we just shared. Now, elements are distinct substances, that's they are pure substances that cannot be split up into simpler substances. Now, that's the smallest of a substance that can exist. Alright, just like cells are the building blocks of biology, of biological organisms, elements are the building blocks of compounds and every other thing, alright, in chemistry. So now each substance, that each element consists of only one kind of atom. Now we are not saying that each element or each substance consists of one atom. There is a difference between consists of one atom and consists of one type of atom. For example, it can consist of one type of atom but have two of the atom. It can consist of one type of atom but have three of the atom. But it can never consist of two different types of atom. For example, hydrogen now. Hydrogen can contain two. We have the H2 gas. Alright? We cannot have H and another element joined together and we still call it an element. No, that's where we talk about compounds. So for elements, the substance consists of only one kind of atom, and the periodic table gives us more details about the elements that have been discovered already, right? And there are over 100 elements known to date, and they are usually symbolized by their capital letter followed by a small letter derived from the English, Latin or Greek name. For example, hydrogen, H, that's one letter. Then sodium, we have two letters, N, capital letter, and then A, right? So they can be categorized in several ways based on the radioactivity. Alright, so based on natural radioactivity, elements are classified into two: radioactive and non-radioactive elements. Now, radioactive elements are those that undergo a spontaneous decay or degradation followed by the emission of one or more of the radiations, which are alpha, beta, gamma radiations. Such elements include radium, uranium, francium, polonium, and thorium. There are a lot of them. There are lots of them. So now, radioactive elements are those that undergo a spontaneous decay or degradation. That's they lose part of their life. Decay, right? So when something is decaying, the thing is degrading. It's degrading in quality and every other thing. Now, non-radioactive elements do not degrade or emit any radiations. They have stable nuclei and would therefore not undergo radioactive decay, e.g. sodium and calcium. So now the key difference now between radioactive elements and non-radioactive elements is that radioactive elements, they decay. Non-radioactive elements don't decay. They don't emit radiation while radioactive elements emit radiation. And most times, radioactive elements, the emissions and this decay are spontaneous. They are not being influenced. When they are being influenced, that is artificial radioactivity. So on a natural basis, when it happens on its own spontaneously, right, those are radioactive elements naturally, but you can actually induce radioactivity on some other elements and substances. So based on properties, elements are also classified into three. We have metals, non-metals, and metalloid. That's based on their properties. It could be physical and chemical properties. Alright, so metals are elements that are ionized by electron loss, e.g. potassium, sodium, calcium, magnesium, aluminium, zinc. We have a lot of them. Now, when we talk about ionized, we are talking about ion. That's metal elements turning to ions. Alright, so what are ions? Ions is just an atom with an electric charge. Now, we have electron, we have proton, we have neutron. We're still going to talk more about this concept But for this context now, we will just focus on what is just needed. Then when it's time to talk about this concept, we'll also talk about them as well. So for example, now, like for example, metals are ionized by electron loss. Now metals have they have little valence electrons. For example, plus one, you understand, they have plus one, plus two. So they are ready to give it out. Alright, they are ready to give it out. They are being overpowered. They may, for example, where we have an electrovalent bonding, whereby the elements, that's the metals, we have to lose their electrons to maybe the halogens, alright, to form a compound or a bond, right? So they are being ionized. Now when they are being ionized, for example, we have an example. Generally metals ionized as follow. We have M is equals to Mn2 plus Ne. N could be 1 2 3. Alright, we have Na plus E. That is the electron. Alright, so electron loss means like electrons are being lost. We have electron is the negative, right? We have proton to be the positive, we have neutron to be the neutral. Alright, so that's that about it. Now let's talk about the physical properties. We'll also talk about chemical properties. Now we have number one to be ductility and malleability. That's metals are ductile and malleable. That's they can be drawn into wires and they can be hammered into sheets. Ductility means they can be drawn into wires. That's why we see that they are useful in making wire cables and fabrication in construction works. Now number two, they are good conductors of heat and electricity due to the presence of free mobile electrons in their lattice. They are therefore useful in making cooking pots, boilers, and electric cables. Now they are being ionized by what? Electron loss. So these electrons actually are kind of free. They keep on, losing an electron on interaction with some other substances or elements. So due to the vibration, they can conduct heat and electricity very, very well. Now number three, we have hard solids with high melting point or boiling point, except sodium, which is soft, and mercury, which is a liquid metal. Alright, mercury is a liquid metal, sodium is soft. Alright, so the others, they have high melting points for sure. You can't see a iron normal now. Why we a iron have a low melting point? Now they are lustrous with silvery color, hence useful in jewelry and in some metallic paint because of their reflectivity. Alright, they say all that glitters is not gold. All that glitters could be silver. Alright, so they are lustrous. Hey, Jesus. Now when you say they are lustrous, they reflect, they are shiny, they are very, very attractive. Now number five, some of them make a sound note when struck. That's they are sonorous, e.g. copper, iron, and aluminium. Such metals are therefore useful in making musical instruments. Yes, that's very true. We even have brass. We have a lot of them. So they are very useful. They are very useful when it comes to, production of musical instruments. They are moderately dense, alright, though some of them are very, very dense. Very dense. We have 14 gram per cm cube, alright. None of the metals is soluble in an ordinary solvent without a chemical change. Yes, there has to be a chemical change for it to be able to, even for example, the rusting of iron. Even for example, the rusting of iron itself is a chemical change. You cannot see iron, undergoing a lot of physical changes that non-metals or other ones could undergo. Right. Now let's talk about the general chemical properties of metals. Number one, electropositive, as they lose electrons to become ionized, hence they are reducing agents. Most of the metals combine with oxygen to form basic oxide. We have copper oxide, we have magnesium oxide, we have calcium oxide. However, some metallic oxide are amphoteric. Now when you say some metallic oxide are amphoteric, it means they can act both ways. They can act both basic and acidic. Alright. Such oxide react as both acid and base. That's amphoteric. Should I say just neutral. They can go well with any of them. Number three, we have they combine with chlorine to form electrovalent chloride. Now the chlorine I mentioned earlier, the chlorine belongs to the halogen family. Alright. Now these ones can just combine with the halogen family to form a stable compound to form electrovalent chlorides, whereby sodium loses its electron, not shear. There's a difference between lose and shear. Shear is when you are talking about covalent bonds. For electrovalent bond, it loses its electron to the chloride. So now they form metallic hydrides that are ionic. They replace the oxygen in an acid if more electropositive than oxygen. That's displacement reaction. We're still going to talk about that. Now non-metals are elements that ionize by electron gain. For example, hydrogen gas, oxygen gas, chlorine, bromine, carbon, sulfur. Right, the ionization of non-metals is as follows. We have examples of that. Non-metals are therefore oxidizing agents except a few of them, since they undergo reduction in their ionization process. The general physical properties of non-metals are they are brittle, that they cannot be hammered into sheet. That's the opposite of malleability in brittle, or drawn into wires. They are non-ductile as well. They are non-conductors of heat and electricity, hence because they do not possess free mobile electrons. However, graphite, a form or allotrope of carbon, is a good conductor of electricity because it contains free mobile electrons in its lattice. Now, non-metals, for example, unless under specific conditions, they cannot conduct heat and electricity. Many gases, e.g. hydrogen gas, oxygen, nitrogen, chlorine, though some of them exist as solid or liquid. For instance, bromine is a liquid at room temperature. Okay, that's true. Iodine is a soft, violent solid. That's to say that not all solids are metals. That's another thing you should note. Not all solids are metals. For example, we even have a metal that is a liquid, which is mercury. So the same applies to the non-metals. We have gases, we have solids, we have liquids. Alright. While graphite is soft, diamond is the hardest known natural substance. Take note, diamond, the hardest known natural substance. Now it says number 4, most of the non-metals are dull and cannot be polished, but diamond, an allotropic form of carbon, can be polished. That is, it is lustrous, it can be made to shine, and can therefore be used in jewelry. It's even very, very expensive. Diamonds are really, really expensive, and funny enough, they are non-metals. But it is really expensive. It can be polished. Alright, so we can now, like, we can also always have exceptions, in even in a class where everybody is average, you usually have one who is more intelligent, one with so that's just how it is in even the metals and non-metals. For example, here we have diamond, which is a non-metal that can be polished and is even the most expensive and can be used as jewelry. They are non-sonorous. For example, you cannot be blowing air and be saying you are playing music, unless you have to make use of some people actually do whistle. I don't see whistle involving metals, but just non-metal. So I don't know about non-sonorous. But let's move to the next one. It says they have low density, though some of them are heavy, e.g. diamond. Yeah, something can easily pass through. For example, you cannot even try to compare metals and non-metals when it comes to density. For real. Some non-metals dissolve slightly in water without reaction, e.g. oxygen, though many of them dissolve with reaction in water, e.g. chlorine, bromine. Some of the general chemical properties of non-metals are: 1, they are mainly oxidizing agents. 2, they form acidic oxides mainly. Now, don't forget, the metals are forming basic oxide, while the non-metals are forming acidic oxides. Alright, so these acidic oxides could include carbon dioxide, could include sulfur oxides, nitrogen oxides. Alright, so the acidic oxide are also known as acid anhydride. That's compounds that dissolve in water to produce an acidic solution, or a solution whose pH is less than 7. Now we have the pH scale. We are still going to talk about it when we come to even in compounds. We're going to talk a bit about acid, bases, and salts. So on a pH scale, where we have acid to be less than 7, and we have the salts to we have the basic to be 7 to 14. Alright, so the salt is actually a neutral one, whereby both, for example, if you mix acid and salt, acid and a base, if you mix an acid and a base, you get a salt. The acid anhydride present in the air are pollutants cause acid rain. Yeah, we must have heard of acid rains. Even it used to be in some dictionaries at the back. However, some non-metals form neutral oxide, e.g. carbon 2 oxide and nitrogen 1 oxide. Should have been nitrogen oxide too. Now we have non-metals combined with other non-metals to form covalent compounds. That they share their valence electrons. They share it. We spoke about electrovalent compounds, whereby sodium is donating, is giving out, is losing its electron to the halogen family or to the non-metals to form an electrovalent bond. But for non-metals, now between non-metals, they form covalent bonds. For example, we have water, to be a basic example. We have ammonia, we have hydrogen chloride, we have carbon dioxide. Now, both metals and non-metals show polymorphism or allotropy. This is the occurrence of an element in more than one form but in the same physical state. These forms are called polymorphs or allotropes. Now, in the same physical state but in different form. When we talk about physical state, you're talking about solid, gas, or liquid. For example, carbon now from the table 1.2, where we have some examples. Carbon now, diamond and graphite, they are both solids, right? But different form. This one is an octahedral shaped, crystal, while graphite is another form of carbon, allotropic form of carbon. So we have sulfur, both of them are actually powder, some form crystals. We have tin, we have oxygen, we have phosphorus. Now, all the allotropes of an element have the same chemical properties, even though they have different appearance or crystalline structures. For example, diamond, a hard form of carbon, and graphite, a soft form of carbon, can be shown to be the same element by combustion, whereby a sample of each allotrope is burnt in excess oxygen. The product in each case is what? Carbon dioxide. Metals are at times mixed intimately with other metals or non-metals to form alloys. Now, alloys is a combination of two metals or a metal and non-metal. Alright, so the alloys combine the strength and the properties of the constituent matter. If you are writing JAMB, this is very important. This alloy is a very important point to take note of. Most especially all that is given in this textbook minus the amalgams. The amalgams are not really common in JAMB question, but you can see the first four of them are very, very common. You should take note. We have number 1 brass to be copper and zinc. We have bronze to be copper and tin. Alright, so just take it that brass and bronze. The brass has a Z. The bronze has a Z already, so it does not need a Z. I don't know if you understand this tip I'm giving you. Brass does not have a Z, so it needs a Z. Bronze has a Z, so it does not need a Z. Now, the Z that brass needs is zinc. Copper is constant. The bronze has a Z, so it does not need a Z. It goes for T. That's tin, because copper is constant. Steel, we have iron and carbon, duralumin. We have aluminium, magnesium, manganese, and copper. Amalgam. Now, anywhere you see amalgam, just know that mercury is involved. For example, we have sodium amalgam. That's mercury and sodium. We have zinc amalgam, zinc and mercury. It should be noted that an amalgam is an alloy of mercury and another metal. Now, the form in which a metal occurs naturally is known as the ore. The ore. In Yoruba, they call it ore. I'm not talking about ore or like as in your friend. Now, a metal can be removed or extracted from their ores by different means depending on their degree of activity. The activity series is the arrangement. Alright, we are still going to talk about this one later on. The activity series is the arrangement of elements in the decreasing order of reactivity or electropositivity or metallicity. We are still going to talk about this where we'll talk about those that can displace those, from reaction, as we discussed earlier, when we're talking about the chemical properties of metals. So let's see right on. It says those metals that are highly or moderately reactive do not occur free in nature, but rather they occur in form of compound in their ores. So we have the activity series, the table here. We have the table here, starting with potassium to sodium to calcium to magnesium to aluminium to manganese to zinc to chromium to iron to cadmium to cobalt to nickel to that should be tin to lead to hydrogen. Hydrogen is like the middle line, right? To antimony to bismuth to unstantanium, what do they call that? AS to copper to mercury to Ag should be silver, Pt platinum, and Au gold. Alright, so we also have some occurrence that's from potassium to zinc. They occur in combined form only. They can be reduced or extracted by electrolytic reduction. So just go through the table. And also you can get these textbooks. If you don't have the physical copy, I'll always drop the link to a site where you can download this PDF and follow up with the classes. So the compound found in ores are usually oxide or sulfide or triazocarbonates of metals. These ores are either concentrated by flotation or roasted heating in air and then reduced chemically or electrolytically to release or free their metals. Elements in this category include potassium, sodium, calcium, aluminium, and iron. So when we start to discuss on the properties of the groups, we are going to dismantle this topic. We are going to dismantle this particular section. We are going to dismantle it. So for now, let's just move on and get to understand better elements and compound. All right, so we have ores, we have the ores, we have hematite, that's for iron, we have cassetrite for tin, we have bauxite. This is not, it's not like they have only one ore. They have others, but what they give you are just the common ones. And lastly, we have malachite for copper. However, there are other metals that have low reactivity, and so they are usually found free in nature. Such metals include platinum and gold. Now, metalloids, we discussed metal, we discussed non-metals. Lastly, metalloids. They are elements that are neither distinctly metallic nor clearly non-metallic, e.g. silicon, arsenic, tellurium, I pronounce it tellurium. The properties of metalloids are intermediate between those of metals and those of non-metals. For example, they are semiconductors rather than being good conductors or non-conductors of electricity. Wow. So that's all on elements. If you don't have, like, if you did not get any part of it, please feel free to drop a comment or reach out to me. I'm surely going to help you understand better. Now we have compounds. So I said we're going to talk about element and compound as pure substances. Then in the next video we'll talk about mixture as an impure substance. So compounds now are substances that compose of two or more kinds of atom joined together in a definite grouping. Now we discussed elements to consist of or compose of one type of atom. Now when it contains of different types of atom, it is a word compound that's chemically combined together. Two different types of atom chemically combined together, that forms what? Compounds. So the properties of a compound are distinct and different from those of the individual elements that are combined in its makeup. This is actually the opposite of mixture. By the time you get to mixture, you understand what I'm saying by saying it is the opposite of mixture. Because for example, mixture, the properties of mixture can, the individual properties exist still in a combined state, but you can be able to identify the individual, properties. There are several millions of compounds known. These compounds are derived from the element, e.g. water consists of hydrogen and oxygen atom in ratio 2:1. Common salt consists of sodium and chlorine atoms in ratio 1:1. Compounds are usually represented by chemical formula, just as symbols represent elements. Another thing is that your compounds must be balanced too. Your compounds must be balanced. Don't go and write HO. What is HO? Write it where OH. Well, you can write HO, but make sure it's balanced, right? Compounds can be classified in a number of ways based on their behavior when exposed to the atmosphere. Compounds are classified into three: the deliquescent, the hygroscopic, and the efflorescent. JAMB also focuses on this question a bit. So please take note their differences. Now, deliquescent compounds are those compounds that absorb mixture from the atmosphere and form the solution of the compound. They absorb moisture, they absorb water, they have in them the moisture. I don't know if you understand, like they absorb the moisture, they react to this moisture by absorbing it from the atmosphere and form the solution of the compound. For example, we have sodium hydroxide pellets, we have anhydrous calcium chloride and iron trichloride. We have hygroscopic compounds. Please, I'm going to say something here, so just pay close attention. Hygroscopic compounds are those that absorb moisture from the atmosphere and become wet. The ability to absorb water from air is less than that of deliquescent compounds. Hence, the solid ones form pasty substances and not solution, while the liquid ones become diluted. For example, sodium triazonitrate 5, copper 2 oxide, and concentrated tetrazosulfate 6 acid. Efflorescent compounds are compounds that give out their water of crystallization to the atmosphere at ordinary temperatures, e.g. sodium triazocarbonate 4 decahydrate loses 9 of its 10 moles of water of crystallization on exposure to air. Now take note, I said I was going to come back to identifying deliquescent from hygroscopic compounds. Now it should be noted that all deliquescent substances are also hygroscopic. but not all hygroscopic substances are deliquescent. Now, if you paid attention, the key difference here is that deliquescent, they form solution of the compound. Look at the definition. They form a solution of the compound, but hygroscopic just become wet. They don't form a solution. Now, hygroscopy is the ability of a substance to draw water vapor to itself and become wet. But deliquescy is when it draws the water to itself and forms a solution. Both hygroscopic and deliquescent substances have the ability. However, if a substance goes beyond being wet and becomes a solution in the course of drawing water to itself, it shows what? Deliquescency. Now, deliquescent and hygroscopic compounds are used as drying agents for gases in the laboratory. For instance, concentrated H2SO4 is the usual drying agent for acidic gases. We have SO2, we have CaO, calcium oxide. They are commonly used. So later on, we'll see real life application of these hygroscopic and deliquescent compounds in drying when we start to talk about reactions, alright, and when we dive deeper. So based on the nature and properties, compounds are also classified as acid, bases, and salt. I said it earlier that compounds, acid, bases, and salt. Acids, they have a pH lower than 7, they form acidic solutions. Bases, they have acids are mainly formed by the non-metals, bases by the metals. Salt is just like a neutral whereby they both neutralize each other. Acid plus base gives us salt and water. So that will be all for this video. I hope you really got it. If you did not get it, please feel free to drop a comment or reach out to me. Now for the next video, we will be talking about impure substances. So we'll talk about mixtures, and then we'll talk about separation techniques. That separation techniques is a very key point you also need to get if you are going most especially for JAMB. Alright, so that will be all for today's class. Thank you for joining. Feel free to invite your friends. If you haven't subscribed, subscribe, like this video, and share. Thank you.